Welcome back, everyone. Just as a recap, before we stopped last time, we had actually built a code in Scratch that was animating a rotating windmill, just like this. So what did we do? We created a rotating windmill block. We drew our windmill. We were also rotating it by 5 degrees every time. Then we were waiting. And then we were making a call to the rotating windmill again towards the end. What else can we do using this particular pattern, right? So in order to give it a try, let us try and do something else. So let me stop this. Let me remove this, but I'll keep the code for the windmill for further references, right, over here. And let us increase the size of the cat. And there you go. If I want to move my cat, let's say towards the right direction or the direction in which he's currently looking at, which is direction 90, which we also set here, point in direction 90. We can use move 10 steps or whatever number of steps, maybe 20 steps, 10 steps, but let's skip 10 steps for now. And if I continue clicking on it, then it moves forward. Oh, but it is also drawing the line. So let's remove the pen down option. And yes, it's moving forward, right? So, okay, but right now it's not drawing the line. So that is fine. So how do we now make the cat move forward in that direction continuously? Let us give the same attempt of what we did for the conditional wind, for the rotating windmill. Sorry. What we did was we created a block. Let us call this block walking cat, right? That's fine. And what was the pattern? We define a block. In that block, we define what we want to do. And then towards the end, we call the same block again, right? And what happens if I make a call to walking cat towards the end? It moves in that particular direction, right? So this is our walking cat. But this is a bit boring, right? It just goes in one direction and then just stops. So what we would do is we also want our cat to bounce across the screen. If it goes on a particular edge, it changes its direction and goes in the opposite direction. So how do we go about doing it? Let us see. So in our every step, it is moving 10 steps. Maybe if we could check if it has hit the edge and then bounce, it should do the trick. Luckily, thanks to Scratch, we don't have to write that much code for it. There is already a block in the motion section called as if on edge, then bounce. So what we will do is we will move 10 steps and then we will say if on edge, then bounce. And the same block happens again, right? So let me first remove it. Let's make it a bit easier to see. So the cat is moving, right? The cat is moving. And while it is moving, if I put if on edge, then bounce here, you can see that the cat is now bouncing over the edge. What will happen if I just change the direction of the cat a bit? Maybe, yeah, there you go. So you can say it's bouncing all over the edge. And how can we make it go slower? Maybe I reduce the number of steps it is going to take. Or maybe something like even 2. Then it goes extremely slow. And you can play around with the value till you get the value that probably you would like to have. And yes, do practice this out. What else can we do with this, right? I'll not change much. I'll probably keep the same structure. That is, we have defined the block. We have given 2 parameters to it, and then we want then we call the same block again. Everything between definition and calling the same block will continuously repeat, as you can see. All right, let's see what happens. The cat is going towards the edge, and when it goes towards the edge, it actually hits the border. The cat must be getting hurt at that point of time. and let's make it say meow. How should we do that? In the sound section, we already have a sound that says start sound. It says start sound meow. Let us give it a try. What happens if I click on that? It says meow. Now what should happen is if it actually hits the edge, then it should say meow. But first let us try and move this here and see what happens. Oh, it's continuously saying meow. That's not what we want, right? So what we actually need to do is, let us actually change the direction again, just like what we did last time. Maybe this looks fine. What we want to do is, if it is really touching the border, then we will say meow. How do we go about doing that? Let us say, just as we said, right? If it is touching the border, then it should say meow, right? So if we are saying if, there has to be something related to the if here. And yes, there is. If, now we need to say is touching the border. How do we say that? Let us see if we get something. So yes, we have touching. So if touching age, then we will say start sound meow. And this we would move after or slightly before if on age bounds. What happens? Let us see. Oh, there you go. Whenever it is going to hit the edge, it is going to say meow. Right? Let us make a slight change over here. We also want the cat. What is the what do we call this cursor as? It's called as a mouse cursor, right? But it looks like at this point of time, cat just doesn't want to go after this mouse. That is not what cats do, right? They'll start chasing things. Let us, like, I'm moving my mouse around and the cat is not chasing it. That's not right. Let us also do that in between. Let us say in motion we have point towards mouse pointer. So let us do that after before we move 2 steps, whichever. Try putting it anywhere. It should do the same thing. And as you can see, it is now chasing the mouse pointer, right? Wherever I'm moving the mouse in whichever direction, even the cat is chasing it, is trying to catch the mouse, right? What will happen if I move the mouse down? There you go. So it is now chasing the mouse pointer that I have. And probably as soon as it catches the mouse, it just tries to play with it. That's pretty good. Let us remove the point towards mouse pointer a bit out. And let us try to do the same action with a keyboard, right? What we want to say is that if I press the left key, then it should rotate towards left. If I press the right key, then it should rotate towards right. Again, as you must have heard me saying this, there is an if part over there, right? So how do we go about saying this? We go to control, we say if, right? What is the first thing that we said? If I have pressed the left button, so sensing, and I should probably say if key left is pressed, then we want to move the cat, also we want to rotate the cat towards left by, let's say, 90 degrees. Let's put the other condition also. Let us say if, let's go to sensing, if the key right is pressed, then we turn the cat towards right by 90 degrees. And this we can put anywhere in the code, maybe at the start of the code or after saying move, and let us see what happens, right? So right now it is not chasing, but as I press right, You can see what it is doing, but it is doing it bit rapidly, right? This is not right. Even if I'm saying left, I need to say it pretty quickly. Otherwise, it just hears the same condition twice and goes around a full circle. Let us fix this a bit. After we say turn left or turn right, let's wait a bit. So how do we go about? So I need to wait for me. It needs to wait for me to release my key. So let's go to control and let us probably say wait. So we say one wait here and one wait here. Right. So what happens? Yeah. So as soon as I press left key, it turns, waits. So as you can see, as soon as I press right key now, it turns right, waits, and then starts moving ahead. If I press left, it should now point downwards. Yeah, as you see. Right? I press right. Again, I press right. It's waiting a bit too long. So let me just say 0.5 and 0.5. This should probably make it a bit more natural. So I'll do right now. Left, left. Okay, it's still a visible time. Let me say 0.2, 0.2. Okay, now this was more natural. Maybe even 0.1 would do the trick. Yes, it just turns naturally and goes in that direction. Play around with the values, and now we have our cat. Now this is an interesting game where we have just made our cat bounce around, but also be able to prevent him from hitting the border using the keyboard. Earlier we tried to do it with a mouse pointer, and now we did it with a keyboard. All right. So practice these steps. We did a windmill. We did an animated windmill. We just quickly built a game involving keyboard control, mouse controls, movement, etc. Using a very simple pattern, as you can see here. Pattern is very simple. We define a block. We put whatever logic we want to repeat inside it, and then we call the same block at the end. Right? That's it. It's very easy to imagine. So essentially what is happening is when you say a flag is clicked, first it will do pen up, then it will do erase all, then it will point go towards 0,0, it will point in a direction 90, and then it tries to do the walking cat step. What is a walking cat step? It first moves by 2 steps, then it checks if the left, I'll stop this, otherwise it will keep saying meow. Then it checks if left arrow is pressed or right arrow is pressed, or if it is touching the edge. All these checks it will do. If on edge, it will bounce. And then again, it tries to do the walking cat step. What is a walking cat step? It's defined here, which is move to 2 steps, check if the keys are pressed, check if it is touching the edge. If it is on the edge, then bounce. And then again, it would try to do the walking cat step, and so on. Right? So we have a cycle here. And that is how the entire code that you have written between the definition of a block or the naming of a block and calling of a block repeats again and again. Give this pattern a try and practice whatever we just did, and then we will resume again. All right. So what else can we do with this? Right, let us first try and do something very simple. For now, I'll take away the code. Okay, it's telling me since I'm already using it here, I can't remove it. Let's start again. Yes, so cat is at the center, but it's sort of floating, right? It's sort of floating in the sky. That's not what generally happens. You just don't float in the sky. You are supposed to fall towards the ground. How do we make the cat fall towards the ground? The simplest thing we could do is, let's create a block and let's call it a gravity, right? Here. And what would generally happen if it's falling? So remember, y, changing the value or incrementing the value of y means going up. So what should we do if we want to get the cat down? We have to reduce its value as and when we go. And what do we mean, like, going down? It's giving a negative value to the y side. So what should we do? We say define gravity, then we change its y value, right? Change y by, let us say, -2. And as we generally see, we call the gravity again below. So we define the block, we change the y by -2, and we ask the gravity to repeat itself. Right? Same way, we put the gravity block here. And let's see what happens. Yes, it's falling down. All right. So yes, it's falling down again. Right? And I can move it up and then release, and it falls down. But that's not how gravity generally works, right? What happens if you take a ball in the hand and throw it down? It does not appear like it's just falling down at a constant rate. This value changes, right? This -2 value that we have, it changes. If it is falling down, it will fall down and it will increase its speed, right? That is the distance that it travels at every step is going to increase. So how do we do that? Right now we are changing the y by -2, but what is actually happening is even this -2 is changing at every point. So what we need to do is when it's falling down, we need to figure out how much it has changed from the last point and also increment that value. Right? So how do we find that out? Let us try and give some value to it. Let us say edit. And since we need to compare it, like whenever it moves, we need to compare it with the starting y position. So essentially what we are trying to do is, let me stop this. Let's say its current y is 68, and then it comes down here and it becomes 15. Right? So it comes down here, it becomes -23. So what we need to do is how much it has moved down, right? So let's take a look at this, 91, 90, and let's say we move it down by some value, it becomes 83, right? So how do we calculate the difference between these two steps? Is we take the starting step, then we move it down, we find a new value, what was the value, and we subtract it out, right? So let's quickly give it a try and see how this would work. So what we are going to do now is, let's give it two inputs. One is the starting y value, right? That is the value which we want it to travel by. And we'll also add another input to it. And here we can say, what is the distance it has to travel? Because this distance is always going to increase. When we go next, we will try and increment this value by a certain amount. And we will say, what should we call it? So distance moved in last step, right? So we have that. So what do we do next? We say, obviously it has to fall down, right? But fall down by how much? So we would always say change y by -2. Obviously that is true, but it has to also increment. So what we are going to do now is we'll take the value and we'll add -2 to it. That is exactly what we need to do, right? If we are falling down, that means we need to take away the value. So how should we do this? Instead of saying -2 here, what I will put here is an operator. Correct? So what's the operator here? Let us say plus. Oh, sorry, I made a mistake here. It is not this. This is actually what we are trying to do over here is gravity, distance moved in the last step, and starting y. These are the two inputs that we need. So what should happen here is, since it is consistently falling down, right? So we'll change y by distance moved in last step, and plus we will say -2, right? If I put the exact same value here for now, everything should just work as it is. So let me say it's 0 here, and we'll see the cat falling down, right? It's picking up the speed. It's taking a lot more speed, so I will say -0.2. It's still falling. Oh, sorry. Even this is different, right? So we will say -0.2, -0.2 here. So at 2 places, and we can see it now appears like it's really falling down. If I make it 0.5 and 0.5, yes, correct. But there's some problem there. It's falling beyond. It goes like it just goes inside the ground. That is not what should happen. So what we need to do is, let us change this a bit. We want to fall only up till this line, till maybe slightly up, maybe slightly low, -130. Yeah, this looks good. So we want it to fall only down to -130. And if it goes anything lesser than -130, we just want to keep it at -130. So what do we want to do here is, we will say if the y position of the cat is less than -130, then we will keep it at 130. So what we do is, we go to operators, right? Sorry, what we want to say here is the current position, right? So yes, if we need to get the y position right now. If the y position is less than -130, right? Then we keep its y position to 130. Set y to -130. All right. So we'll put this here. But then there's a problem. So it has stopped, but what would be this value when it is going to call it again? This should be the distance moved in the last step, right? It will continue to increment, because we have not put a stop here, and it has actually changed lesser this time, because it is not currently moving down, but this will continue to increase. This value will continue to increase. So how do we get the actual value? We have a starting y, right? All we need to do over here is, we need to calculate what is the difference between the starting y and the new position. So how do we do this? Normally, any code that we do will be, I need a subtraction operator here. We need to find a difference. So we say starting y minus the current y position after applying the change. And for that, let us go here. Right? And my current y position becomes the starting y position in the next step. Let us do the same thing here. Let us put the starting y position at this point also, and let us move. So what's happening over here is we are changing the y by the distance moved in the last step, and we are incrementing 0.5 to it. But looks like our starting y and minus y position does not work, because it's giving the positive value. Because the starting y is always greater, right? We need to swap it. And now we will get the more realistic effect, as you can see. That is exactly how things appear to fall down. All right. So we have our own cat that falls down. Let us start a bit higher. Let us say y being 110. There you go. And it stops when it falls on the ground. All right. Let us quickly do one more thing. Let us also make it jump when we press the space bar. Now, how do we do that? Is this condition is fine, but what we need to do now is if we have pressed a space bar, we need to push the cat up, right? If if falling is negative, what is pushing up would mean is negative of negative, right? Which makes it positive. So we'll do the same thing. We'll change its y by a positive value. So let us try doing that. What we are saying is, if I have pressed a space button, that is, if let's go to the sensing part. If I have pressed space, then in the motion, change y by, it has to be obviously greater than what the gravity's force is. So gravity's force currently we are saying is minus 0.5. If we keep it to minus 0.5, what would happen is it will just stay there. It will not go up, sort of. So let us say change y by maybe 1, right? The positive side. And let us put this code before we end it. You can try putting it wherever you want, that is fine. But let us say it is falling down. Now if I press space, there you go. It sort of jumps up. Let me increase the value, change y by 2. And now it jumps higher. So this really looks like it's actually jumping up and then it's falling down, right? If you press the space bar for a longer value, it will jump higher and higher, then it will fall down. Right? This is exactly how the real world looks like, right? You jump up and then you fall down. Right? There's a game called Flappy Bird or something, which is based on a very similar idea. You can try building a game like that using this flow. But for now, this would need some practice for you all. So take your time, do practice this aspect. Try to remove certain blocks out, see what exactly it tries to do. Try to solve this values or try to solve the steps on a paper, and you will slowly understand how this works, right? Till then, enjoy playing it. It's cut for now.